Hello, I hope you all are perfect with the synopsis of complex numbers and the formulas so that we can do multiple choice questions from this lesson. Let us look at the first question without wasting time. If omega is a complex cube root of unity, then the value of a plus b omega plus c omega square by c plus a omega plus b omega square plus a plus b omega plus c omega square by b plus c omega plus a omega square. We have to get one of the values. So here you must remember two important formulas with omegas. One is 1 plus omega square is 0 and the other is omega cube equal to 1. So because omega cube is equal to 1, here I can write a into 1. Here also I can write a into 1. So that this one over here, this one over here, I can write as omega cube because 1 can be written as omega cube. So the given expression will become a into omega cube plus b omega plus c omega square by c plus a omega plus b omega square. In the same way, plus this one also I can write as omega cube. A into omega cube plus b omega plus c omega square by b plus c omega plus a omega square. Now immediately I get a thought that I can write omega also. Like this b omega, I can write. How? If I know omega cube is 1, then if you take just omega and multiply both the sides to omega cube, you multiply omega, to 1 also you multiply omega. Then from this you can say omega power 4 is omega. That means instead of this omega, we can write omega power 4. Again, b omega, we can write as omega power 4. So that now I can take common omega square in the numerator. So I have a omega plus b omega square plus c. And denominator also I have the same a omega plus b omega square plus c. Same way in the second fraction also, when I take omega square common, I will have a omega. But here I don't have a omega. I have a omega square. So I cannot take omega square common. What should I take common here? Instead of omega square, I have to take just omega common, not omega square, because then only I will get what I want. So when I take omega common, I have a omega square plus b omega cube plus c omega. But because I know b omega is 1, b omega I can take as 1. Down also I have same a omega square plus b plus c omega. So that I can cancel these two and I can cancel these two. So left is omega square plus omega. And then from the first formula I wrote, omega square plus omega can be written as minus 1. So the final answer will be minus 1. You can go to option C. Let's take the next question. In the second question, it's given that if xn equal to cos of pi by 2 power n plus I sine of pi by 2 power n, then the value of x1 into x2 into x3 up to infinity is. So actually, this is in mod amp form. So the mod amp form I can write in shortcut. If you remember while explaining the synopsis, I told you. I can write xn as cis pi by 2 power n. Now, because we have x1 into x2 into x3 up to infinity, that means we are multiplying cis pi by 2 power 1 into cis pi by 2 square into cis pi by 2 cube and so on up to infinity. Because if you want x1, you have to put n as 1, n as 1. If you have x2, you have to put n as 2 and here also n as 2 and so on. This is what we get. Now, already I told you while explaining that when you multiply the cis, you will write cis, but you will add up all the angles. That means you are adding pi by 2 plus pi by 2 square plus pi by 2 cube up to infinity. Or I can take pi common. So 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to infinity. So this is infinite geometric series. In infinite geometric series, the sum is given by the formula a by 1 minus r. A means the first term and R is ratio of consecutive terms. So here, first term in this geometric series, A is 1 by 2. And ratio, you will take consecutive terms. Consecutive terms means you will take second term, first term. Second term by first term will give you the ratio. That means 1 by 4 divided by 1 by 2 or 1 by 4 into 2 by 1 or 1 by 2 is the ratio. So once you know A and once you know ratio, you can find the infinite geometric series by A by 1 minus R. So this will give rise to cis pi into 1 by 2 by 1 by 2. So 1 by 2 and 1 by 2 cancels. You will have cis pi. Now if you expand the cis pi, it is cos pi plus I sine pi. Full form. Now cos pi is minus 1 and sine pi is 0. So final answer will be minus 1. If you know the theory part or the synopsis which I told you, easily you can do the problems by yourself. Let's go to third question. If B plus IC equal to 1 plus A into Z plus, this is not A2, B2, C2. This is A square plus B square plus C square. So A square plus B square plus C square is 1. Then you have to write what is 1 plus IZ by 1 minus IZ. Now, after looking at the question, I have to find 1 plus IZ by 1 minus IZ. So what I will do is first I will take this given information and I will write Z is equal to B plus IC by 1 plus A. So first of all, I got what is Z. Now I will multiply I on both the sides. Here also I will multiply I, so that I will get 1 by Iz. I'll take the reciprocal, will be 1 plus A by, when you multiply this, you will have IB plus I square C. I square is minus 1. See, what I did is I took the reciprocal. I took the reciprocal this side and I took the reciprocal here also. Because I can write this as 1 plus A by IB minus C. Because I know I am writing the formula I square is minus 1. Now, after getting two ratios and looking at the question, I get the idea that we can apply componendo and dividendo rule. What is componendo and dividendo rule? I'll write dividendo spelling again because it's not looking clearly. Yes, the spelling of dividendo, componendo and dividendo rule is you will take numerator plus denominator by numerator minus denominator. The other side also numerator plus denominator by numerator minus denominator, both the sides. This is only componendo rule and this is only what we have to find as per the question. But the thing is, as you can see, I have to simplify a little bit. Not little bit, much. So for that, this is division sum. So I will take real part 1 plus A minus C on one side and the imaginary part IB on the other side. Similarly, in denominator also 1 plus A plus C real part minus IB imaginary part. Now, in synopsis, I gave you shortcut formula for multiplication divisions. A plus IB by C plus ID. First, if you write the real part, it is AC plus BD by C square plus D square plus I into imaginary part is BC minus AD by C square plus D square. The same division formula we will apply here so that we can do this sum quickly. So when you take this as A, okay, B is same, this as C and this as D. With minus also you have to take minus B as D. So what you will do, first you will multiply AC. When you multiply AC, what will you get? You see, I am doing it separately. When you multiply A and C, 1 plus A minus C into 1 plus A plus C. Just like A minus B into A plus B. So that will be A square minus B square. So this is what you will have. AC means when you multiply AC, what will you have is 1 plus A whole square minus C square. Then plus BD. B and D when you multiply, you will get minus B square. Denominator C square. 1 plus A plus C whole square plus D square minus B whole square. This is real part. In imaginary part, what you will have? BC. BC means B you have to multiply. B plus AB plus BC minus AD. So minus, and here one more minus is there. So that will become plus. Minus and minus will become plus. Now you have to just multiply A and D. So when you multiply A and D, what will you have? B plus AB minus BC. Denominator same, 1 plus A plus C whole square plus B square. Now, the next step I am writing here. You will have 1 plus A square plus 2A. Take minus B square plus C square in the numerator. What about denominator? Denominator we have to expand. This I have to expand. So 1 plus A square plus C square plus 2A plus 2C plus 2AC and then plus B square. Similarly, in the imaginary part, I into, what will you do here? Imaginary part, you can cancel BC and BC. So what is left? 2B plus 2AB. Denominator same. 1 plus A square plus C square plus 2A plus 2C plus 2AC plus B square. Okay, further, how can you simplify? If you see the question, in the question, from this, B square plus C square can be written as 1 minus A square. From this given information, B square plus C square is 1 minus A square, which I am going to write here. So I have 1 plus A square plus 2A minus 1 minus A square. So minus will change the sign. 1 will become minus 1. Minus A square will become plus A square, and down 1 plus, I can write A square plus B square plus C square as 1, because in the question they gave that as 1. And then I will write plus 2A plus 2C plus 2AC. Here I will take common 2. And I can take B also common. So that I will have 1 plus A. Denominator will be same. 1 plus A square plus C square. Okay. 1 plus A square plus B square, I have changed it slightly. So whatever I got in the denominator, the same thing I will write. 1 plus 1 plus 2A plus 2C plus 2AC. Same this denominator only I will copy. Now further, if I want to simplify, if we simplify, 1 and minus 1 will cancel. I can take A common. Even now you can take common, or you can take later also. Next step, 2A square plus 2A I will write. Then I will write 2 plus 2A plus 2C plus 2AC. I'm writing one more step so that it will be clear to you. I into 2B into 1 plus A. Denominator same. 2 plus 2A plus 2C plus 2AC. Now I will erase the top part. Because we don't have space here. So to create space, I'm erasing on the top so that I can use to write this. The left of question I will write. Let me erase it completely, neatly. Yes. This work is over. Now, coming to the question. Here, I can take out 2A. So I will have A plus 1 by denominator. Here I will take 2 common. So I will have 1 plus a, and here also I will take 2c common, so that I will have 1 plus c. In the imaginary part, 2b into 1 plus a, the denominator will be same, 2 into 1 plus a plus 2c into 1 plus a. Now, still further simplifying, I will have 2a into 1 plus a by 1 plus a I will take common, I will have 2 plus 2c. Similarly, I into 2b into 1 plus a by denominator 1 plus a into 2 plus 2c, the same. So that means 1 plus a cancels, 1 plus a cancels. So final step, where should I write? I will erase and write. Componendo dividendo rule. Actually, we were finding 1 plus iz. This is what we were finding. So I will write here. Let me erase this completely. The steps are little bit longer. It is little bit difficult to understand, but it is normal algebra. Squaring, multiplying, taking common, dividing. That's why it will be easy. Okay, so I was finding 1 plus iz by 1 minus iz as per the question. So I will have 2a by, take 2 common, 1 plus c. Then plus I into 2b by, again take 2 common, 1 plus c. So 2 also cancels. And finally, 1 plus c is the common denominator, a plus ib is left. So that belongs to option D. Next, coming to question number 4. If Z1 and Z2 are any two complex numbers, these are actually to be written as Z1 and Z2. Then here, this is also mod of, I will write here, mod of Z1 plus square root of Z1 square minus Z2 square plus mod of Z1 minus square root of Z1 square minus Z2 square is. Okay. To find this, we must know one formula. That important formula I am writing on the top. Formula I will write with the blue color, so that you can easily see what is formula and what is question. The formula we have to use is mod of Z1 plus Z2 square plus mod of Z1 minus Z2 square is 2 times mod of Z1 square plus Z2 square. This is the formula. Why did I say we have to use the formula? Because in the question, this is imagine it is Z2. This is imagine it is Z2. So somewhere we will be using this formula, not now, but later. So first, how will I start is, I will take Z1 plus Z2 whole square. That means I am taking Z1 plus square root of Z1 square minus Z2 square. This entire one plus Z1 minus square root of Z1 square minus Z2 square. This entire one I am squaring it. So when you square, what will you have? You will have a square. Z1 plus square root of Z1 square minus Z2 square. A square. Then what is the formula? A square plus b square plus 2ab. So b square z1 minus square root of z1 square minus z2 square whole square. And then minus 2ab. That means I have to multiply what? 2ab means. So actually what I did, I will tell you. Don't get confused. I have taken this as A and this as B. So I took A plus B whole square, for which I got A square plus B square. Now plus 2AB I'm getting. So how to write plus 2AB? There I stopped. So what is A and what is B? This is A, this is B. I have to multiply A and B, 2AB. So when I multiply, this is actually looking like A plus B into A minus B. So this is actually A square minus B square. So 2AB, when I multiply A and B, I have to write A square minus B square. So A square is Z1 square minus square root of Z1 square minus Z2 square whole square. A square minus B square. This is what I have. Now here, I will use this formula which I wrote on the top. You can see this formula. Where I'm using here Z1 plus Z2 whole square plus Z1 minus Z2 whole square will be 2 times Z1 square. What do you have? 2 times Z1 square plus Z2 square. What is Z2? Square root of Z1 square minus Z2 square whole square. This is what I have for these two together. For the next term, 2 times Z1 square minus square root and square will cancel. So minus, when you take it inside, minus Z1 square plus Z2 square. This is what you have. So remember what formula I am using here. What formula I am using? A plus B whole square. A square plus B square plus 2AB. After that, for this Z1 plus Z2 square plus Z1 minus Z2 square, I am using the formula which I wrote here. 2 into Z1 square plus Z2 square. So I wrote here 2 into Z1 square plus Z2 square. Okay. Here I have written 2 into Z1 square plus Z2 square. And the last one, this I have simplified here. Now, after doing this, what can I do? Here, again, I repeat what I did here is, see all of you. This is 2 into Z1 square plus Z2 square. And this is nothing but what we got here. We have simplified. Nothing difficult. Okay, so I will write 2 into Z1 square plus square root and square will cancel. Z1 square minus Z2 square. And here minus 2 into these two will cancel. Z2 square you will have. So if you see here Z1 square and Z1 square, what do you have? They won't cancel, isn't it? Both of them, they won't cancel. So what will be left? 2 into Z1 square plus 2 into Z1 square minus 2 into Z2 square minus 2 into Z2 square. So total, what do you have? 4 into Z1 square minus 4 into Z2 square. This is what is left, isn't it? So you can take 4 outside. You are left with Z1 square minus Z2 square. How will you write 4 into? How can you write 4 into Z1 square plus Z2 square? Any idea? 4 into Z1 square minus Z2 square. You can write it as Z1 plus Z2 plus Z1 minus Z2 whole square. I will tell you how. This 4 also you can erase. For that I have to use some other color. How did I write this? Imagine this is A plus B plus A minus B and then whole square. Imagine it like this. So what will you have? A plus B plus A minus B whole square. 2A minus 2B whole square. This is what you have, isn't it? So the same thing I have written. I will write this as let me first erase it. So I will write this as 4 into Z1 plus Z2 into Z1 minus Z2. Isn't it? So we don't have this option anywhere. In any of these, we don't have. We don't have this as the option, this as the option, this as the option, or this as the option. We did not get any of the options here. That means we have to modify it in a different way because this is not working out. This method is not working out. We have to use the option in another way. But as I said, the formulas will be same. What is the first formula I gave you? The first formula I gave you is, yes, here I'm writing. Z1 plus Z2 whole square plus Z1 minus Z2 whole square is equal to 2 into Z1 square plus Z2 square. So use this formula. At the same time, we must get one of the options. So how to get that? It depends on that. So first I will write whatever is there in the question. In the question we have, let me change the ink color. Yes. We have mod of Z1 here over here. So if I have something like a formula which is familiar to you, I will write. If you have A plus B plus A minus B, if you have like this, if you want this, so what you have to do, you have to take A plus B whole square plus A minus B whole square. Or you have to take A plus B plus A minus B whole square. So the first formula I will be using while solving is A plus B plus A minus B whole square. This is the formula I will use. I'm telling you in an easy way, the shortcut way. A plus B plus A minus B whole square I will use. So if you use A plus B plus A minus B whole square in this case, in the question, what we have. So what I will have is I will start with this first. I'll put an arrow. I will take Z1 plus square root of Z1 square minus Z2 square plus Z1 minus square root of Z1 square minus Z2 square. And then I will square it. So this is easy formula for you. It is A plus B whole square. So I will have A square, I will have B square, I will have 2AB. So that I will write one by one slowly. First I will write A. This is my A, which I am squaring. Then B. Z1 minus square root of Z1 square minus Z2 square is my B, which I will square it. Then plus 2 times, this is my A, Z1 plus square root of Z1 square minus Z2 square into, this is my B, Z1 minus square root of Z1 square minus Z2 square. So this is A square plus B square plus 2AB. Now, here only lies the trick. What to do will be lying here. So, when you do this, we will be using the above formula what I wrote here. This is Z1 plus Z2 square plus Z1 minus Z2 square. So, what I should have? 2 times Z1 square plus Z2 square. This is what I should have as per the formula. So I will write that only. How to write? 2 into, what is Z1 square? This is Z1 square. Plus, what is Z2 square? What is Z2 square? Square root of Z1 square minus Z2 square whole square. This is what you have. And then from the left of ones, what is left of? That we are going to see here. 2 into, now I will multiply these two. So when I multiply these two, which formula I will use? I will use a different color now. So this is A plus B into A minus B. So I should have A square minus B square. So when I use that formula, A square means Z1 square minus B square. This will be squared. So square root will go and minus is there. So the signs will change. Z1 square will become minus, Z2 square will become plus. So these two will cancel. See, this method will be easy compared to the other method I told. So 2 into z1 square plus, here also square root and square will go. So z1 square minus z2 square you will have. And here 2 into z2 square you will have. So how can I write this? Now this became a very shortcut form because we are doing it like this, isn't it? So I will take 2 into z1 square and this 2 into z2 square together. And then left of 2 into z1 square minus z2 square I will take separately. So that here I can take 2 common and I will have z1 square plus z2 square when I take common. And here simply 2 into z1 square minus z2 square will be same. Now I am writing here. I will use the formula which I wrote on the top. 2 into z1 square plus z2 square. How will I write? z1 plus z2 whole square plus z1 minus z2 whole square. And this last one, 2 into z1 square minus z2 square will be same. Or I can write z1 plus z2 square plus z1 minus z2 square. This a square minus b square, I can write a plus b into a minus b. Why am I doing like all these? Because to get what is there in the options. This is looking like a square plus b square plus 2ab. So I can write a plus b whole square. This is a plus this is b whole square. This is the final answer which I have here. A plus b whole square. This will be the answer. So you have to take none of these. Option D. In the previous one also, previous method also, I got nothing. No option I got. None of these only. In this method also, I got no option. None of these. But this is shortcut method and that will be the long way. Okay, I think we have gone through these questions and we have taken a lot of time for this. So we can go to the fifth question. The smallest positive integer n for which 1 plus I whole power n, actually 1 plus I by 1 minus I together has whole power n. So here I will tell you one shortcut formula. You have to remember this because in most of the sums you will get this. Whenever you have 1 plus I by 1 minus I, you can take it as I. Remember, this is the shortcut formula. So using this shortcut formula, I will write 1 plus I by 1 minus I is I power n equal to 1. Now in the question they are asking us what is n. If you take I as 0, I power 0 is 1. But they don't want n as 0, the power n as 0. Because it should be positive integer. 0 is not a positive integer. Okay, if you take I power 1, it is I. It is not 1, but we want 1. So n equal to 0 you can't take, n equal to 1 you can't take. If you take I square, it is minus 1. It is not equal to 1. So n equal to 2 also you can't take. If you take I cube, it is minus I. It is not equal to 1. So n equal to 3 also you can't take. If you take I power 4, yes, this is 1. That's why you can take n equal to 4. So n equal to 4 will be the least positive integer which we can take. But again, here n equal to 4 is not there. So you can go for none of these options. Okay, let us go to the next question. The next question is, if P is the fx of Z in the Argand diagram and P moves so that Z minus I by Z minus 1 is always purely imaginary, then the locus of Z. The locus of Z means equation for Z, or Z lies on which circle, Z lies on which square, Z lies on which parabola, like that. Locus means that. So first of all, we will take Z as Z equal to some complex number x plus iy. So they gave us Z minus I by Z minus 1. So Z I will write x plus iy minus I. Z I will write x plus iy minus 1. So in the numerator, x is the real part. I into y minus 1 is the imaginary part. In the denominator, x minus 1 is the real part. Iy is the imaginary part. So this is just like division problem. And for division problem, I gave you shortcut method. A plus IB by C plus ID is equal to, the real part is AC plus BD by C square plus D square plus I into imaginary part is BC minus AD by C square plus D square. But because they are saying the answer for Z minus I by Z minus 1 is purely imaginary, that means it will have only this imaginary part. It will not have this real part. So this real part should be 0. It should not be there, means it should be 0. So what I will do is I will take AC plus BD by C square plus D square, and I will take it equal to 0. So imagine when we are using the formula, I must know what is A, what is B, what is C. This is A, this is B, this is C, this is D. I will take only real part, AC. So what will happen? AC means x into x minus 1. Then plus BD, y minus 1 into y, by C square, x minus 1 whole square plus y square equal to 0. Or I will have x square minus x plus y square minus y equal to 0. X square plus y square minus x minus y equal to 0. So this is the equation of the circle. Easily, because in coordinate geometry you have learned. I will give you that formula also, because maybe some of you don't know. If you have x square plus y square plus 2gx plus 2fy plus c equal to 0, it is the equation of circle whose center is minus g minus f, and radius is square root of g square plus f square minus c. So first of all, I must know what is g. This is x square plus y square. So I know 2g is minus 1. When you compare, 2g is minus 1. And then 2f is minus 1. And c is 0. So g I will get minus 1 by 2. F I will get minus 1 by 2 and C as C. That means for the circle which I am talking about, the center will be minus G minus F. And radius will be square root of G square plus F square minus C. That is 1 by root 2. So center is 1 by 2 comma 1 by 2 and radius is 1 by root 2. It is option C. I hope this question is clear to everyone. Okay, let's go to the next question. The next question, that is the seventh one, is the number 1 plus I whole power n by 1 minus I whole power n minus 2. Just now in one of the questions I gave you formula. What is 1 plus I by 1 minus I? It is I. So what I will do, the question is, numerator I will take 1 plus I whole power n. Denominator I will take 1 minus I whole power n into 1 minus I whole power minus 2. Denominator I will break, because for this whole thing I can take common 1 plus I by 1 minus I whole power n. And this, because of the negative power, I can bring up 1 minus I whole square. So this is I power n. And this is 1 minus I whole square. So until here, I got it. Now, how to get the answer which I want, which is there in the options? I must get only that. So I have to manipulate it. I have to change it. What will I do to change? I will write I power n 1. I'm taking a minus b whole square. A square minus 2ab plus b square. Now I can write 1 minus 2i. I square is minus 1. So that 1 and minus 1 will cancel. So I have I power n outside and minus 2i inside. If I see, this option is not there. I don't see this option in any one of those. So I have to make some changes. What are the changes I am going to make? I will take 2 I power n plus 1. And then this minus 1 I will take down. So 2 I power n plus 1 minus 1 I will write it as I square. That means 2 I power n plus 1 minus 2. So 2 I power n minus 1. This is how I manipulated to get this. Sometimes you won't get the option directly. You have to change it in order to get the option which you want. Okay, let's go to the next question. Eighth question. If omega and omega square are complex roots of unity, then 1 minus omega plus omega square whole power 5 plus 1 minus omega square plus omega whole power 5 is equal to. So here again, we must know two important formulas which I told you with omega. What are those? 1 plus omega square is 0 and omega cube is equal to 1. So based on this formula, here I can write 1 plus omega square minus omega whole power 5. Here I can write 1 plus omega minus omega square whole power 5. What I did is omega square I got in between. Here omega I got in between. That is because 1 plus omega square. 1 plus omega square, I can write minus omega from the formula. Whole power 5 I have to write. But before writing that, if you see in the brackets, there is one more minus, isn't it? See here, what I did is, let me be more clear. See, from this formula, I wrote 1 plus omega square is minus omega. So 1 plus omega square, I wrote minus omega, but this minus omega is also there, whole power 5. Plus, similarly, 1 plus omega, from this formula only, 1 plus omega will be minus omega square. So I will write minus omega square, one more minus omega square, whole power 5. So this will be minus 2 omega whole power 5. This will be, sorry, minus 2 omega square whole power 5. So I will have minus 32 omega power 5 minus 32 omega power 10. When I will take minus 32 common and omega power 5 common, I will have 1 plus omega square. Again, 1 plus omega square, I wrote on the top, it is minus omega. So what I will have? 32 omega power 6. Omega power 6, I can write omega cube whole square. And omega cube is 1 square. So in that way, final answer, I will get 32. Let us go to the next question, because we have to do as far as possible, at least 10 questions we have to complete it quickly. Okay, next question. If omega equal to z minus I by 1 plus iz whole power n, n is an integer, then omega lies on the unit circle for what values of n? That is what they are asking. So first I have to take this omega. The omega, it is actually not omega here. So you must recognize it is not omega. It is just a complex number W. So this complex number W, I can write it as Z minus I. In the bottom, 1 I will write as minus I square plus IZ. So that and then I'll write whole power n same. I'll write Z minus I. Then I will take I common, so that I will have Z minus I left. Z minus I and Z minus I will cancel. And so I am left with 1 by I whole power n. Or I can write 1 by I power n. Just simplifying and manipulating. Now what I can do is, I can multiply I up and down. I can multiply I up and down. So why I am multiplying I up and down instead of writing like this? If I want to modify it, I have to take like this. Quickly I will finish. I have 1 by I. I will multiply I here. I'll multiply I here. Whole power n. Then I will have I by I square whole power n. And then I by minus 1 whole power n. Then minus I whole power n. So this minus I whole power n, how can I take? This is W, a complex number. If I take modulus of this complex number, That means I'm taking modulus of minus I whole power n. That means I'm taking modulus of minus I whole power n. That means I'm taking modulus of 0 minus I whole power n. So modulus will be square root of 0 square plus minus 1 whole square whole power n. That is 1 power n. That is 1. So if modulus of a complex number is 1, that means square root of x square plus y square is 1, or x square plus y square is 1. So this is a circle, unit circle, irrespective of I, for all n, whether it is even n or odd n. For all n, it represents unit circle. So we don't have time to complete more questions from this chapter, but in the next class, we will be doing some more questions. Around 11 questions we will do, and then we will go to the new chapter. Meanwhile, practice more problems and go through the problems which we have practiced. See you in the next class.